I mean, oh, all right, great. Leave meeting. Leave meeting. Make it go away. Hang on.
Y'all ran him off.
Did he leave? He did leave.
All right, we'll start. Okay. Oh, okay. I see. I clicked the wrong. All right, I got it.
Technology is hard.
All right, let's share a screen.
You got two choices and you screwed it up.
That's a chance. I got it wrong. Lovely. All right, we're in business now. I don't know what the hell I did. All right, let me pull back PowerPoint. What are we talking about? Okay, Wonderbar. All right, so did we get this far?
No.
We got to your first slide, and then you were gone.
Okay, so this is Synapse. So it's a cloud-based architecture. It wraps a lot of different services together, right? So it brings in what used to be SQL DW, is now known as what's called a dedicated pool. And that's an MPP data warehouse kind of posable, scalable solution, similar in some ways to something like Snowflake or Redshift. Serverless Pools is part of the Synapse space. It's more of a serverless technology, so what that means is you don't really have any local storage. You're just querying over files. So that's similar to something like a BigQuery or maybe an Athena. I think in AWS. I don't know for sure. And then you have some other stuff. So it integrates with Power BI. It integrates with machine learning, Purview, data share, and there's a unified kind of web experience that we'll look at. And so one of the misconceptions that I want to drill home to everybody is that I can spin this Synapse workspace up and not have to pay anything for that, as long as I'm not running a dedicated pool. Oh, and it also has Spark pools, right? So the ability to kind of do kind of like a Databricks, and we'll talk a little bit more about what that entails. But so there's different types of compute, and the idea is they want to unify it and give you kind of a single user experience to work from, which is called the Synapse Studio. It also supports pipelines, so I can do kind of ETL and orchestration, so data flows and data factory type stuff, kind of similar stuff there, and supports like HTAP scenarios. If I want to link to like a Cosmos DB, or if I want to link to streaming data, I can stream that data directly in there. So the idea is it's one kind of unified experience to bring all these different types of technologies together, right? And so serverless is a piece of that. And so when I go to provision this in Azure, I will create a Synapse workspace, and then I can turn pools on and off, and I only get paid as I'm running resources. So it's an important thing to understand, because even if you're not using Synapse, so let's say if you come to me and say, Jason, I don't really need Synapse, I don't have a lot of data, there's still, I would argue, a use case for you to use serverless pools potentially, or even other parts of this, right? So with that being said, let's move on, and feel free to interrupt at any point if there's questions. So if we think about it, what is it really at its core? It talks to an Azure Storage account, and one of the really cool things that you guys will see, that storage account doesn't even need to be in that same tenant or subscription, right? So I can use public storage accounts. That's got to be Azure Storage. So unfortunately, it doesn't at this point connect to like S3 or other types of storage. It's got to be an Azure Storage account. It can be a blob storage. It can be a Data Lake Gen 1 storage account, or it can be a storage account V2, okay? And it's an on-demand service, so I query, I run queries through it. I can use Management Studio. I can use Azure Data Studio. I can connect to it with Power BI. To the outside world, it looks just like a SQL Server endpoint, right? Now, it doesn't have complete feature parity. We'll talk about some of the things that you can do there. And then one of the cool things is it can kind of integrate with some of the metadata in an Apache Spark pool. So what that really means is that if in Apache Spark, if I create a external table over some files, Synapse can see that table in its database space as well. So there's some caveats around that, but it's kind of cool because Synapse, we'll talk about it later, it only supports a limited number of file types. And so if I need to do like some crazy parsing of like a custom EDI file or XML or something that Synapse doesn't support, I could do that work in a Spark pool using Python. or any of the .NET or any of the other languages, dump that data out to a file that it does support, like Parquet or CSV or JSON or Delta Lake, and then access that from Serverless Pool. There's a couple different use cases that I see for this. So one is this notion of a logical data warehouse. So Databricks is calling this their data lakehouse architecture. So this would be one way to build a lakehouse in Azure, and using the Synapse would be to use a serverless pool to create kind of a lakehouse. And all that really is you still have a data warehouse, you still have dimensions and facts, but you don't have it inside of a relational database. You have it in a logical structure laid out over your files. And we'll talk a little bit more about the implementation about that. And the key thing here is you pay only for the query execution, and you don't query for time, or you don't pay per time, you pay for the amount of data processed. And we'll dive into that in a second. So any questions before we move on? Wonderful. So if you're familiar with the old SQL DW architecture or the dedicated pool, you have DWUs or data warehouse units, and that's a unit of compute. And in order to run a query, I have to turn the query on. Other services like Snowflake are always on, right? So I can run a query and it does some adaptive scaling there. BigQuery, things like that are more similar to how serverless pools work. So what's cool about it is it's always sitting there, right? And when a query comes in, it's going to go to this control node, and it's going to look at the query. It has access to statistics and all the things that the SQL cost-based optimizer does. Comes up with a query plan, and it figures out based on the statistics it has and the size of the data, how much compute to assign to it. And then it runs that query across those nodes. So it takes advantage of processing it in parallel. And in theory, it returns it back fairly quickly. Now, a couple downsides to this. One of the big things to be aware of is if you have anything that takes longer than 30 minutes, it will time out, and there's no way to control that, right? So you want to really shoot for running things that are less than 30 minutes. So if you think about like normal queries, like end users aren't going to wait for 30 minutes to get a query result back. But if I'm running some kind of an ETL process, I need to optimize it so it runs in less than 30 minutes. You pay for the amount of data. So it's, we have a slide on that coming up. And the native file formats it supports in those storage accounts are Parquet, JSON, CSV, or delimited. So it can be tab delimited or comma separated. So any kind of flavor like that. And then recently in preview is the Delta Lake file format. Now with Delta Lake, it only supports read. Serverless does allow you to write data out, which is, we'll talk about how that works and why you might want to do that. And then if you want to know more about kind of the internals of how this works, the internal code name for this was Polaris, and for the distributed query processing engine. And this is a white paper that they published that goes into all the details behind it. One of the bad things about this is you don't have a lot of metrics available to you as far as like how many files you're scanning. It will tell you how much data you read in terms of megabytes, and it will tell you how long the query took, and there's some other kind of limited metadata, but you don't have the insights into like your weights and that kind of level of intelligence into it. So that can be a problem when you want to performance tune or troubleshoot this. And it's the main scenario that I see this being really useful for is if you are primarily trying to serve your data through a BI semantic model, whether that's Tableau or if it's Power BI or if it's Azure Analysis Services or Tabular, and you just have a relational data warehouse just to serve as a place to pull the data from for that data model or for that tabular model, then this is a great technology because you can store all your data very cheaply, right? So it's much cheaper to store it in Azure Storage than it is in a database. And then when you go to process it, you can process it through these queries, and then your refresh occurs, and then your users aren't running directly against this, right? They're running against the cache version of the model. The other scenario where this can make some sense with a lot of caveats is if you have a scenario where you have very simple aggregations, right? So you wouldn't use this if you had really complex calculations, but you have very simple data and it's very, very large, so that it would be prohibitive to keep it inside of an Azure Analysis Services model. So if you think about model sizes, once you start getting over, I'd say 50 gigs in Azure Analysis Services, it starts getting really cost prohibitive. And so if your model's that big, then you could put direct query and query against your Parquet files, which is a columnar data structure. And so if you're doing very, very kind of simple sums and counts and amounts of data, it could give you kind of a reasonable performance as long as your model's very simple and you've kind of tuned the partitioning and some stuff there. So something to think about there. And it's good for if you need to do kind of ETL transformations that scale out across a lot of data. So we'll walk through that in a little bit as well. But it's not built, it'll support occasional, like if I want to ad hoc query it and, I've got 30 or 40 other people running queries, like it'll support that fine, but it's not really meant to be an interactive system like that, right? That's not its strong suite. It can do it. But right now there's not really a very good caching layer in there. So every time I query a set of files, it's going to go read the files, right? There's no notion of like a buffer pool, like what you have in SQL Server to cache things, right? So, there is some performance that you can eke out of the storage account by doing premium and stuff like that. But, you get reasonably good performance. You get consistent performance generally. This is just a little slide on, the shared Metastore. So the idea here is if I create this table, and this is a notebook in Spark. So this is using what's called a Spark SQL to basically create a table, dumping it out as Parquet onto a blob storage here, and using this URL. And then you can see here when I go into my Synapse workspace, I can query it from my serverless environment, right? And so the idea there is I could create table definitions in one. It doesn't go the other way. It just goes one way from Spark to serverless. But if I'm doing some ETL in Spark to do complex processing, I don't want to have to redefine those table structures, right? So that there's some functionality there that can be useful. More so if we start thinking about costs, right? So it's $5 per terabyte of data processed. So it's very cheap to run these, right? As opposed to if I think about like a SQL Server, I could be paying $1,000 to $2,000 a month to keep something online, 24/7. Whereas this, if I'm running queries, think about how much data is in a terabyte. And so what you actually get charged for is the amount of data that you read and then the amount of data that you return, right? And any kind of intermediate things that happen inside the engine. But you always have insight when you run a query into how much data was processed. It'll tell you, and it'll break it out by that, right? So I read, 200 megabytes of data and I returned 5, right? And so the cost is 205 megabytes. The costs are rounded up to I believe to the nearest 30 meg. So no matter if I run like a select top 1 from a file, it's going to charge me for 30 megs worth of data consumption, right? So you get a sense of how cheap this could potentially be. There's no need to pause or resume anything, no need to manage scale or to provision it. It in theory will scale to the size of your data and your needs. You may struggle a little bit sometimes to get the performance you need if you don't partition things correctly and lay it out correctly. And we'll walk through some best practices around that in a little bit. So let's see. You do have some control via the portal and via T-SQL where I can set up kind of cost control numbers. So I can see how much data I've used, as well as I can set a weekly limit. I can set a monthly limit, so I can put caps on these so that we don't have things going wild. So if a good use case for this is, let's say I have some really crazy transactional, like maybe I work for a telco and I have call level transaction detail that hardly anybody ever needs access to, but once in a while they need to do a deep dive audit into it, or maybe it's like web click stream data where I need to see the individual clicks once in a while, like somebody does a deep dive on that. So they can go to this and access that through the files. But then I could also, every day, I could roll it up to a daily level. And so I might have, 1 billion records in a single day. They might get aggregated up into 1 million records, right? So I might be looking at something per hour or per day, things like that. So I can definitely like aggregate stuff up and I can hit these things directly. So again, these are really the scenarios we're talking about. So some data exploration. So oftentimes if you're starting, if you're starting to build out a warehouse, you don't want to go through like the design of relational tables and, you've got some files. This is a great way to just, if I have some CSV files or some JSON files, dump them into a data lake somewhere. I don't need to write ETL to ingest it into a relational data warehouse. I just put queries directly on top of those files, right? Data transformation at scale. So if I need to move data between containers and accounts, I can do that. But really what I like to do this for is to transform data. So if I have a big CSV file and every night it has a full set of records, I could do a full outer join with yesterday's CSV file and work out the deltas between those and then save those deltas out and then load that into my warehouse. So I can kind of use it as a transformation engine to reproject, aggregate, transform, do all sorts of kind of stuff with it. And that's where I can bring in Spark and kind of have the best of both worlds there. And then if I just need that logical data warehouse where I'm going to expose primarily the data through some kind of semantic reporting tool that's cached, but occasionally people need direct access to the underlying data. But I don't want to incur the cost of running a relational data warehouse. This could be a good solution, especially if the data is super small, right? If the data is really small, potentially even if it's larger, but I would say it can make a lot of sense, just to make it much simpler and quicker to get to kind of a prototype, right? Without having to do a lot of ETL code. I won't have to muck around with SSIS or any of these other things. I can just build views and external tables, which we'll talk about in a second. So how does the querying actually work, right? So first, we need to understand the sources. So we've got text, JSON, Parquet, and then recently they have Data Lake. So that slide's a little bit out of date. I think there's some kind of a hack that you can do to get access to CDM. You certainly could access those through Spark, I believe, but it's not kind of a supported thing. There is no support for Avro or ORC files, which is probably fine. Most people probably aren't using those. I would definitely recommend putting this on a storage account generation 2. So not use blob storage or not use Azure Data Lake 1. And the other thing that's really important to note is I can't do any inserts or updates or deletes, right? There's no DML because there's no storage locally. All the storage is going to read directly against what's in the file. So it's primarily a read technology. I can write data out to a new file, but I can't update an existing file. And I don't use an insert to write it out. I use what's called a create external table as select or a CETAS statement, which we'll talk about. So everybody probably understands CSV. It's a common comma separated text file format. It's human readable, so that's beneficial. Does support some compression, but it can generate very large files, right? But a lot of data interchange uses CSVs. So this is an example using the open row set. And so what it does is it basically says, I've defined an external data source, which we'll talk about in a second. I'm going to use a CSV format. Parser version 2 is the faster version. First row is 2, so I'm going to skip the file headers. And then I'm going to parse the CSV file and return the top 10 rows from it, right? Support for different type of row terminators. So this is a little bit more complex, but key thing here is I've got a field terminator of a comma. My row terminator is a new line, so /n, which is a carriage return line feed. So that's Windows style. And then here I've actually defined the data types, and that turns out to be kind of important from a performance standpoint. So you notice in the other statement, I didn't have to do that, but if I do, I can control what data type this is. Otherwise, it just uses inference and it picks a data type for me. So it return everything as strings, which isn't what I want. So here I'm using year as a small int. So I'm sharpening that data type to take advantage of, making it the optimal data type. And population could be a big int. And then I've got 2 varchar values, and I can specify collation. We'll talk a little bit. You have to understand a little bit about collation, especially when you're working with Parquet files. So we'll talk about that in a second. And notice here I can put a predicate on this too. So I can filter on country and I can filter on year, and I can create statistics on CSV files. It automatically creates statistics from us on Parquet files, but I could actually create statistics on this to help it generate a better plan, right? So that would just return this row set. Unix style. So in this case, we just have a line feed. So notice that the RowTerminator has changed a little bit. I'm still doing kind of the same query, and it's just a different data set. So nothing too exciting. If I'm using tabs, then I can change the value of the field terminator. And also notice that I'm skipping the first row here. I'm doing first row 2. So that would be how I'd process a CSV with, or sorry, not a CSV, a tab separated values file. Okay. So this is just a summary of the different terminators. We'll talk more about the JSON terminators. Those are kind of a weird edge case, but that's difference between Unix and Inline or Windows, right? And then horizontal tabs. So anyway, this is all kind of ASCII kind of goodness. I can have quote characters. I'm going to kind of skip through some of this stuff because it's not super interesting, but just note that if I have strings that have commas inside them, I can specify a field quote. So in this case, it's a double quote to kind of escape it. And then I can, if I have characters that I really want to escape, I can escape those by defining an escape character too. So this is a little bit talking about the schema inference. And there's a function you can get to actually figure out what data types is being returned, because it's not immediately obvious sometimes from the result set. So in this case, it's just going to use schema inference, and it's just going to load the top 1,000 rows or top 100 rows into this tabular structure. And so this works both for Parquet and CSV. JSON is kind of self-describing, so there's some stuff there that you need to kind of shred the elements out, which we'll talk about. I can define things inline. So here I've done that. So one thing I can do, let's see if I have an example of that. So notice here, I'm actually giving you a fully qualified path to a URL. So the assumption with this, since there's no security information in here, is that this is a publicly accessible blob, which is probably a bad assumption. There's not going to be a lot of those out there. But I can specify the full URL, and I don't need to define an external data source or a file format. I mean, here I specify CSV, but that's not the same thing as a file format. So we'll talk about that in a second. So what I would do is, if I wanted to kind of save this information, or if I needed to pass a credential with it, I can create an external data source. So here I'm creating an external data source to this URL. So it's to this on-demand blob storage, and I'm using this SQL on-demand credential, right? Here I'm creating one that's an open storage, so there's no authentication in here, and it's just giving me, and it's going to map me to this yellow. So anything after this, I could add in that bulk section. So if we look back at that, if the subfolder was like yellow/foo, then I could put here foo/ and then star.csv. So I can kind of simplify the expression there a little bit. So it's just important to know what type of storage account, and especially for Data Lake Gen 2, there's two different APIs, right? There's dfs.core, which is a storage account Gen 2, and then there's blob.core, and storage account V2 supports both of those, whereas blob storage only supports one of them, and then Data Lake Gen 1 has a different URL. So you have to make sure you're using the right URL for the storage account, and that you have access, which we'll talk about a little bit later. The other cool thing too is we've just looked at examples that parse one file. Here I can actually call out and put wildcards in there, and I can then parse multiple directories or multiple folders. One thing that you'll notice here is, year equals, and then star, and then month equals 1, so that's hard coded, and then star.parquet. So what that's going to do is it's going to look underneath the taxi folder, and for every year every year folder that it comes across for the first month, so for January, it's going to process, or it's going to return all the Parquet files underneath that, so star.parquet. And so it'll process all these different year folders, but only the first month, right? Now, there are functions that we have that can give us access to these specific values for these wildcard functions that I'll show you a little bit later. So if I wanted to say, only read files from 2015 to 2020, I could do that, and it would only read the data from those files. It wouldn't read other files, and that can be a performance improvement. So we'll talk about that in a few seconds. I can also, and that's these functions, right? So this file path 1 equals 217. So if you see what's happening here, I have 2 wildcards. Well, I have 3 wildcards in here, right? So this is the first one is going to be year, right? The second one's going to be month, and the third one's going to be star.parquet. And so if I say row set is this, and it's defined as R, and I say r.filepath1, that's saying give me this wildcard, and it's saying the value is in 2017. So what that would look like is year equals 2017. So it's just going to filter me to 2017, and then file path 2 is going to be the second wildcard, and it's going to say give me the months October, November, and December, and there you have it, right? So it's only going to if this had folders for 2018, 2019, 2020, it's not even going to look in those folders, right? Now, the best practice is, even if we're doing this elimination here, if there's let's say there's a field in there called date, calendar date, right? Or what data set is this? Say it's taxi data. So if the field is like trip date, you still want to put another predicate on there that says where trip date between 2017 10/1 and 2017 12/31 to logically protect, because even though this will only read those files, there's no guarantee that in this 10 folder we don't have data for September, right? That somebody could have messed that up. So we still want to, even though we're using the partitioning to do the elimination, we want to redundantly specify a predicate that makes sure that we can't return that data. Okay. And then this is known as like Spark or Hive style partition data. Anytime you see this year equals, some programs, in fact with Delta Lake, you'll see that it automatically gives me a field. If I put it against a structure like this, it would give me a year field, a month field automatically, just by having the column year equals X, right? And the value would be populated correctly. So JSON is interesting. You can get that from a lot of different websites these days. And the key thing is you have a lot of name and value pairs. Go ahead. All right. So, everything's separated by name value pairs. You have commas that separate the elements. Integer values don't have quotes. String values have quotes. Notice there's no date time field. So any date time parsing you need to just make sure you have a valid time in there. You can have arrays, so it does support nested data. So I could have multiple children in here. And so when you have these complex nested data types, you have to have a way to parse that out, which we'll talk about. Usually you can have explicit nulls in here, but usually you'll omit those. You can have Boolean values here, and you can have decimal values, right? So here's a null value. A lot of times in JSON, it just won't see it. So it's a very flexible file format. You can have what's called single line JSON, which is this kind of structure where you just have an array with multiple lines. And in this case, each line is a row, right? And so there's a special way you just specify the vertical tab for the field terminator, field quote, and row terminator. And this will load the entire document into a single row. And I'll show you guys how to parse that out in a second. Or you can have multi-line JSON where each row is an entire element, right? And so each of these is an actual valid JSON data structure. So in that case, you just specify this special 0x0b value for field terminator and field quote, and then you can query it. So here's an example where we're going to query it, and we're using the JSON value function to say from this document. So what we're doing is we're opening this JSON file. Notice that there's no format equals JSON, so we just call it a CSV, and we set the row field and quote column to the 0x0b, and then we call that doc as an nvarchar max, because SQL Server doesn't have a JSON data type either. It has you use a varchar max, and then you use some JSON functions. So the 3 main JSON functions are JSON value, which returns a single scalar value. JSON query, which can return a query, so multiple types of values, or open JSON, which returns a data set. So what we're doing here is we're saying, okay, return doc, and then from doc, I query using JSON query or JSON value. So the first field is the actual JSON column that has all the data in it. And I'm saying, give me the metadata.title, give me metadata.title, and authors is an array. So I'm getting the first element of the array. I'm getting the first name here. So that's one way to parse that JSON. And this is a little bit more atypical, I would say. So the next use case, we'll kind of skip over this. There's some different rules, like if I'm using JSON value and I'm doing something that, for example, is if I query out address, and address isn't a complex object, so that just means that address has different attributes, it'll return null because it expects a single value back, right? I can't get the root of it because that's a complex value. If I have tags, which is an array, I won't get those back using the JSON value function. Oh, sorry about that. Type though works, right? So type equals basic. I have a scalar value, so that'll work. Info.type, so I can go root of the document, info.type scalar value, it'll return it back for me. Okay. Now, if we flip that and use JSON query, it kind of reverses itself, right? So I can get address back as a JSON object because it's complex and I'm doing a query. I get all my tags back because tags is an object using the query, but type, since it's scalar, is going to return null. And there's a strict mode parsing and there's a lax mode that will either return an error or it'll return null if you have a type mismatch. Okay. Open JSON is pretty slick though. So, and this is probably 9 times out of 10 what you're going to want to do. So same kind of concept here. The main difference is that I cross apply the doc value with open JSON, and then I just define the columns that I want in here. And notice I can have different expressions in here. So this is going to be a different element, or if it's just off the root, it would just pull it through, and I can cast it to an appropriate data type. Notice I can put predicates once I define that. So I've defined this country column as there's a .countries and territories field, and I can link that to a predicate in the query, and I can order it by those fields as well, and then I can return the value. So this helps us kind of shred the JSON and break into our nested JSON levels. But it can also be used against single row data so that we can kind of simplifies the processing. So you notice what I don't have to do is do all these individual, all these individual JSON value and JSON query structures inside of here by doing that cross apply. So that's kind of a shortcut. So Parquet is kind of a columnar structure. I just simplify it and just say it's very similar to a column store index. It stores data compressed column-wise. And it's really great for analytical workloads, right? So if I'm doing a lot of analytical queries, I don't want to have to parse through JSON or CSV. So if I get the data in it in that raw format, first thing I'm going to do is write it back out to a Parquet file if I'm going to do analytics on it, right? And it also has very good compression, lots of different types of compression, and support for predicate pushdown. So it maintains internal statistics within the file and the column to basically do very limited, so if I'm scanning a file, it'll tell me what's the max value and the min value for a column. So it can be very efficient in terms of how it reads data, reads the files very quickly. It's going to be a lot slower to write data out to Parquet because it has to go through that compression. But typically what you're doing is you're writing it out once to Parquet, and then you're not rewriting it out again. If you need to add more data to a Parquet file, what you usually do is read the current Parquet file, join it with the new data, and then write it back out. And that's, in some ways, that's kind of the drawback of Parquet and why Delta Lake's so popular. Delta Lake allows you to insert and update data into a Parquet file, basically. So a little bit of internals, we're not going to dig too far deep into that, but the key thing here is it's stored in a columnar manner. So doing group bys and aggregates, especially if there's not a lot of joins and stuff like that, is very, very efficient on a Parquet file. We're going to skip over that. So this is just showing just some different ways of tracking Parquet. The key thing to understand about this is you want to make sure you use this collation on your database, or you override it at your column level in your with clause, because this matches the internal Parquet sorting rules for strings. So there's two kind of main drawbacks with using Parquet files. The first is, those sorting orders need to match. If they don't, you don't get the predicate push down, and there's a little bit of performance impact. It'll still kind of work. But the other thing is, if I don't explicitly define what data type, so Parquet does know about data types, but it treats all strings as the same length. And so if I ran this select star top 10 star from this ECDC cases.parquet file, every string column is going to come back as a varchar 8000, right? So there's two problems with that. The first problem is if the string actually has more than 8,000 characters, it's going to overflow and it'll throw an error. The second problem is if it's a varchar 50 and I have 100 different columns, at some point SQL Server is going to say it's too much data, and it's going to say I can't process all this data, and it'll throw like a nasty error. So what you want to do in that case is actually explicitly cast the string data to the appropriate column size. So if I'm loading data from a relational structure and I know that field's a varchar 100, or I know if it's a 100 character field, I'm going to want to define it as a 100 character field. On the flip side, if I know it's a really big comments field, or if it's a big JSON field, I want to declare it as a varchar max instead of a varchar 8000 in case it overflows that. Okay, so that's really important to not use it. It can be very easy to get lazy because Parquet will give you generally reasonable data types, but you want to explicitly define these data types for better performance and not running into errors down the road. So what you can use these different file formats, like I said, Parquet is really the best one for analytics, but you might get data in CSV and you might choose to keep it in that CSV format just because it's human readable and a lot of tools. There's probably more broader support for CSV files. And a lot of your APIs, your web APIs, and a lot of even programs now are exporting data via JSON. So you might need to use this. It's becoming more of a common data format. So, and the benefit of JSON and Parquet over CSV is it supports complex types. That just means that it can have nested arrays, and it can have different objects with different properties inside of it, like we saw with the JSON example. So I'll pause right there. Any questions? Okay, so let's talk about the data transformation. This is actually what I think is the most interesting part, is I can use this serverless pool if I get files to perform transformations in the file system before I load it into a relational database, or I can perform the transformations to generate a file and then load that file into a tabular model. So I can restructure the data, I can reshape it, I can build SQL-based ETL pipelines, I can orchestrate it with Azure Data Factory or the Synapse pipelines. So a key thing to point out is just because I have that Synapse workspace set up and I'm using Synapse Serverless doesn't mean I need to use the pipelines from Synapse, right? I can still use Data Factory to run my pipelines, right? So, and it can still talk to the data. At the end of the day, it's just a SQL endpoint. So the way we do data transformation in serverless is to use the CETAS statement. And so it creates an external table. I give it a location. There can't be anything there, even an empty folder, right? So if this population folder exists, even if it's empty, it's going to throw an error. I can specify a data source and a file format. So in this case, I create a file format called Parquet file format. It just tells it that it's a Parquet. So we'll walk through the definitions for that in a second. The data source is presumably giving me my URL and providing the credential. And then I just run any kind of query. And this can have joins on it. I can do group bys. I can do pretty much whatever I want. And it's going to write this data out to a Parquet file stored at this population location. And then the file is going to be called parquet.population. And I can run select queries from that. So you can see I'm doing that select query down here. And here's just an example where I'm doing some aggregation, right? So I'm grouping it by, I'm filtering it to the year, and then I'm grouping it by month. and then I'm running a count query across it. And so it's going to write that result out. And so what I might do is I might build a process in Azure Data Factory that let's say every month it sums up all my data to a monthly level. Like maybe it's a GL account, right? And so after they close their period, I roll all my debits and credits up to a single ledger entry for the month, right? And so each day I build a snapshot of where we're at in the current month. So anytime you have that accumulating snapshot fact table, not accumulating snapshot, periodic snapshot fact table, this would be a great pattern to do that in and use very cheap storage, because those tables get very big very quick, especially if you're snapshotting them like every day, right? So that's one use case. So that's kind of this aggregation, right? So here I have, whoops. I've got a bunch of bank account balances, and then what I'm doing is getting a daily balance summary, right? So that's just doing some group buy-in and maybe doing some windowing functions just to give me the daily numbers. The other case is doing delta detection. So if I have today's file and yesterday's file, I want to know, and what I can do here is do a full outer join between the two files, say who's present in here and not present in here. So in this case, if this is my current file, John's there, right? So I do a full outer join, and if that join succeeds, 1 equals 1, right? Then I ignore because it's present in both, assuming that the name is the same, right? Sally is in today's but not in tomorrow's, so we could potentially insert. Sue is in today's but not in tomorrow's, so I could do a soft delete, right? Or I could just ignore it, right? It just depends on what the business logic is. But that way, if I have a vendor that won't give me an incremental file, rather than loading, let's say my customer list is a 10 gig file and I get a 10 gig file from the vendor every night, rather than trying to load 10 gigs into SQL and doing the logic in there, I could basically do the delta detection by keeping the current snapshot and today's new file and run the delta here, and then just end up loading the inserts and updates, right? So that might just turn that 10 gig file into 100 megs of new data, right? So any kind of manner of delta processing, and not Delta Lake, but like, delta detection. So did the file change, or do I need to add new data? Do I need to transform the data before I load it? So maybe I'm getting daily transactions, but I'm loading it into maybe I'm getting, debits and credits, and I need to roll it up into a daily transaction first. I could do that outside of the database. It's going to be a little bit faster potentially. Okay, so let me come back. Or I might just need to do it to change the data type. So in this case, I get the data as JSON and I want to dump it out to Parquet, or I want to dump it out to CSV. I might need to, optimize the format. So sharpen the data types. So make them, turn strings into dates, make sure the logic is there to handle, malformed data or missing data. If I have nested objects in my JSON, I can flatten those out, remove unneeded columns. I can compress data. So the data might be coming in as CSV, and if I dump it into Parquet, it's going to compress it in the Parquet files. Parquet file is going to be smaller. So those are all good scenarios. And I can do that just by creating a view. So I can create a simple view, but it's still going to do all that work every time I access it. So that leads us to the notion of creating an external table, which we'll talk about in a second. So here I've built a store procedure that creates this external table. So this is not the same as the CETAS, or sorry, I take that back. This is doing a CETAS. It's grouping the data, and the store procedure is calling it. What I want to show you guys is I lost it. Let me talk through that in a second. Let me actually show you guys a quick example of what that might look like. Where did that go? Move this out of the way. Okay, so what the external table looks like, and this is a kind of a key thing to see here. So you can see I'm creating a view, and that's based off of another view. That's fine, but I'm
Hey,
actually
Jason?
giving it a data. So yeah, go ahead.
I just see a blank screen.
Oh,
Anybody
shoot,
else?
sorry. How about that?
There we go. Yep.
Sorry about that. Thank you. So this is an external table where I'm basically creating the external table and giving you the location and the data source. But what it's going to do is it's going to populate it on demand, right? So once I run this, it's going to create the table and store the data, and then I can run queries from it. When I actually create an external table, I already have the files that are there, so I point it to a location, but I don't have a select statement. And instead of a select statement, I use the with block, and I define which columns and data types that those files map to, and it lays it on top of it. So that's something where maybe there's another process that's creating this data, and it's just going to lay on top of it, as opposed to this actually generates the data, but then makes it persistent, right? So let's see. Let's take a look at something a little bit more interesting here. So you can see, like here, I've got the open row set. I'm creating a CSV. I've got a header row equals true. And then I'm putting a predicate between there. I'm doing a group by. So a lot of different logic here as well. Joining the data, so on and so forth. Let me skip over to something else. Grab this thing out of my way. Give me a second. Pull it up. And where's my ADS at? Okay. So get this out of here. So here I have a notebook. And what you'll notice about this is I've connected with Azure Data Studio to my serverless pool. And if I look at it in here, so I just have a database connection. And let's see, that's doing some metadata. So I can run this query that's going to do top 10 against this JSON file, and it's going to give me a result set. So this is showing me the JSON row data. You can see what happens when it runs. I can tell what the query hash was. So that's just an identifier. It also tells me how much data did I scan. So in this case, I scanned 5 megabytes, and I moved 1 megabyte and I wrote 0 megabytes. So it's going to charge me for 6, and it'll round that up to I think it's either 10 or 30. In this case, I scanned 16 megabytes and I moved 59 megabytes, right? So it's going to charge me for what, basically 76. Let's see what else we got. So from Parquet standpoint, we talked about this UTF-8 collation, talked about explicitly defining data types. Here I'm running from a Parquet file. So there's a .parquet file, and I'm just using file format as Parquet. And there you can see I get my rows back, right? So that's all fine and good. I can also use an external data source. So the syntax for that is just create external data source. In this case, what's interesting about this is see how this URL, there's no security against it. If I go over here and let's see, move this guy over here and go into my storage explorer, I can see that I can connect to the SQL on-demand storage and see the blob containers in there. And I can actually see all these data sets, right? So I can go in here and browse around. And these are all those demos that we looked at, right? So if I wanted to play, and I can just hook into this data, it's not my storage account, right? It's Microsoft's storage account. And I can connect to it and play with this data and run queries against it, right? So if I want to play with this, and all these sets, I'll show you guys another thing here in a second, but all these data sets, you can bring them into your workspace. So let me show you guys that real quick. There we go. Bring that over. So if I go into, so this is a Synapse workspace that I created. If I want to know how to get that endpoint, I can go here and get this serverless endpoint. So this is the server URL that I'll put in there. And then I'll connect with my AD account. It does support SQL authentication as well. There's a little bit more gymnastics I have to go through to set up the authentication through to the storage account, but I can log into it with a SQL-based account. So, maybe I have a SQL account called Jay Horner, and then that SQL account could access the underlying storage account. So if we go to this workspace, and give that a second to fire up. And this is basically the Synapse Studio. Of course, it's going to ask me for a password, and I probably don't remember what it is. That's okay. Oh, come on. Really? All right, I'm not sure what's going on there. Let me try it. Holy cow. If this doesn't work, I'm gonna try one more thing. I don't know if it's something with the Wi-Fi or being signed in somewhere else, maybe.
Failure to make appropriate sacrifices to the demo gods.
I don't know. It was working. It's working over here, so I'm just going to bring it in from my other workspace. Give me a second. I think it's probably this. So you have two different hubs, and so this is the data hub. And notice that my serverless endpoint is here, and I can see all my external table definitions. I can see my views, my external data sources. Right, so this is connecting to different zones in my data lake. So I can set those up. I have views that are defined, right? And then I can create schemas. So I create a database. So in this case, I've got a database called ODS, and then I've created schemas within there for ref, DW, so on and so forth. So I can organize this just like I would a regular SQL Server data warehouse, and then build views to populate in those objects. So if I want to write scripts against this, the other environment is this develop hub. And so I can just create new scripts here. So I could do a new SQL script and just write the script, and then I can save it, and it'll save it into source control if I have it hooked up. The other cool thing that I can do, though, is I can go into here, and let's say I've got an external table set up. So like client dimension, I can actually generate a new SQL script that'll give me a top 100 rows from that. Or what's even more powerful is that if I go over here to this linked, it's going to go into the storage accounts that I have defined. So rather than using Storage Explorer, which I showed you guys earlier, I can go in here, and here's all my data lake data. So I can go into here, and I can go into my demo folder, and I can go right click on, I think I can right click on this, and I can say new SQL script, select top 1000 or 100 rows, right? It automatically created this thing for me, so I don't need to memorize all that complex foolishness, right? And then what'll happen is it'll query it for me, and I can see this is just a metadata table that I use to drive some different things. So 2 columns. Notice that there's not a header here, right? So I kind of screwed up on the definition because there is a header, but it just called it C1 and C2 because I didn't tell it what the header was mapped, but I could easily fix that. I do have messages here. So this is something, remember when I was talking about the UTF-8 collation? You'll get this warning. It's pretty innocuous for CSV files, but like I said, it has pretty severe performance impacts for Parquet files. The other thing that's useful to do is I can go to manage, and I can look at my, where is it? I can look at my built-in pool, and this is where that cost management section is, where I can set up the cost control. And I should be able to see how much data. So I ran 10 megs of queries today. This week, 1 terabyte, this month, 3 terabytes, right? So if we think about it, that's $15. And that's me cranking on this thing pretty hardcore for the last 2 weeks, or last week, I guess, since it's the beginning of the month. So you can see I can set up those quotas. The other thing that I can do, let's cancel all of that, is I can go into here and I can look at my SQL requests. This trips a lot of people up. So notice the pool here. If I was running dedicated pools and I don't see my data, I can switch over to dedicated pools and it'll show that. So here I got my built-in. So this is going to show me my queries. And you can see how much data each query cost me, right? Who ran it and the duration, which is kind of cool. And then if I click on more, I don't get a ton of additional information. I can just see the actual SQL statement. So there's not a ton of metrics. I think if I click the request ID, I can just kind of see that and get a little bit of metadata, I think I can export it out. I can edit a copy of this. So if this query errored out or something, I can capture it from the log, but it's not super robust, right? I don't get any weight stats. It doesn't really tell me which files were scanned, which would be super useful, I think, to validate the performance. It does tell me how much data was scanned, which I guess is useful. So that's how I can monitor that. Let's see, what else can we show? I think that is pretty good. This is still trying to connect, so that's not helping us much. I wanted to show you guys a little. The Delta Lake stuff is kind of new, so I put together some just really quick demos on that. We already talked through a lot of these demos. So with Delta Lake, the only difference is I now have a format equals Delta, right? And here I'm just showing that I can create an external data source on it. Again, since Delta's under the hood, it's a Parquet file format. It's going to, oh, holy cow.
Can you explain Delta Lake a little bit?
Yeah, let me get to it real quick. Give me a sec. Okay, so what Delta Lake is if I think about a Parquet file, like I said, the drawback there is I can't insert, update, or delete rows from a Parquet file. So if I need to do that, what I would do is I would grab all the data from the existing Parquet file, do the modifications via query, and then write it back out, right? So usually doing a join or whatnot. What Delta Lake allows me to do is actually create kind of a virtual table that I can do inserts, updates, and deletes on. And then it behind the scenes, it manages it. In fact, we can actually look at it. So show you guys what this looks like under the covers is I can go into this Delta Lake container. And if I go into COVID, I've got a Parquet file, and then I've got a log file, right? And so the log file is like a T-log in your database, and it enables me to do things like time travel and go back to points in time. Some of that functionality is kind of limited depending on whether you're using Databricks or the open source Delta Lake format. But the idea, the primary use case is for doing things where you have streaming data that's constantly arriving, and you need to be able to write the data out to Parquet, and it's arriving all the time, and you aren't doing kind of a batch workload. But they also use it for, kind of creating table structures inside of Spark databases so that I can insert and update and delete records. I can query from it, right? And I can query to a point in time. There's some advanced indexing that it supports. The other interesting thing too is if I go to here and look at this yellow structure. So notice here I've got that Hive partitioning with the year equals, and then I've got months, right? And so and then underneath here I have all these different Parquet files, right? And so this was generated by a Spark job. So these are the Spark job identifiers. And then it's using snappy compression, which is kind of like a compression mode, and it's just a Parquet file. But the point of showing you guys all that is that if I go in here and run my Delta Lake query against partition data, there we go. So I have that year and month, right? That's what we just looked at. If you look at my predicates, I don't need to call that file path. It just gives me a year and month attribute that I can filter on. So it does the intelligence to know that if you have anything with that year, value equals X, the column will be named what the value is. So in this case, it's named year, and then the value will be whatever is on the other side of the equal sign, right? So I could partition it by client or by database or by time is pretty common. Usually it's in a multi-tenant system, it might be like a client. In a normal system, it might be year, month, day. If I have multiple facilities, it might be year, month, day, facility, right? I could have lots of different ways that I might partition this data out. So that's kind of cool. So it automatically kind of infers those for us, right? And so notice here, it's just giving me my 2017 and 0 through 19. So doing months 1 through 3. Then notice here, this is what I was talking about. So just because it's doing this partition elimination on the actual physical Delta Lake file, you still want to use this additional predicate to make sure you're getting the right date range, right? So it's just going to look in these file formats, but it's going to go from 01 to 3/27/17. So that's Delta Lake. So I think just to tie this up, let's go back to the deck and talk about this logical data warehouse concept, and then we'll wrap up here in about 10 minutes, I think. Oh, whoops, there we go. So the idea here is that we've got all these table structures that we've defined, and those can be views, they can be external tables, and those are building out kind of our logical facts and dimensions. They're all based on file structures, right? And that works really good if I've got a caching layer on top of it, like Azure Analysis Services or Power BI data models. And they just need to refresh, once a day, once every hour, 4 times a day, something like that. It doesn't need to live in a SQL database. And we can use these to do transformation logic. Now, can I use M in Power BI or even M in the tabular model to access these Parquet files directly and do those transformations? I can, but if I don't know M, it might be harder to do what I'm trying to do in there. And if I know SQL, anybody that wants to hit this with a SQL connection can have the benefit of that transformation, right? So if somebody wants to connect to this with Excel and just see the data, or they want to run it from reporting services or paginated reports, or they just want to connect with Management Studio, like I showed you guys, or Azure Data Studio, all that transformation's been done, right? I can take advantage of that. And I can put security on top of it, right? So I can put permissions on who can access all the permissions I can do in SQL, right? I can do on top of those tables. So I can give kind of another layer of permissioning. So the first thing I usually do is I'll create a database. I'll specify the collation because I'm going to use Parquet files. So that'll get my default collation. Without getting too far into the weeds, this UTF-8 basically allows me to use varchars instead of nvarchars to store that data. There's pros and cons and trade-offs to that, but this can save you a lot of space, but you have to be aware of some of the caveats. Then in here, I can just create a schema, right? So I create a DW schema. So that's good practice to kind of logically create structures inside your database to keep tables organized. Then I need to start creating logins, right? So I can create, this is a UPN. So this would be my Windows credential from external provider. That just means I'm going to use Active Directory. And then I can add Jenny to the server sysadmin role, right? Or I can create her as a user inside the database, right? From that login and add her to DB Data Reader, right? And I can create SQL logins as well. This is an example of that file format. So I create a Parquet file mount that just says file. I just specify 2 options really. The format is Parquet and the data compression is either none or snappy, right? And then I use that file format in my external data source. Here's a file format for a text file. So this would be a pipe delimited file with string delimiter, right? So I can create as many of these as for the different file formats that I need. And then I don't need to re-put those options in everything that I run through. Again, the external data sources, we already kind of looked at that slide. What I do need to do to be able to save credentials is I gotta have to create a master key. I don't have to provide a password, so, but I can. If I want the Synapse identity to have rights to something, so the Synapse workspace has an identity. So if I create a database scope credential called SQL on demand, and the identity of that is going to be that Synapse workspace, and I can give rights to that to, you know, a database or a file share. I can assign those rights. What else can I do? So this is an example of the CETAS statement, right? So creating this external table, I can put statistics on it, right? I automatically get statistics as a Parquet file. If I want to create an external data on files that already exist, so in this case, these files are already there, then I just need to define the data types and give it a location and a file format. If I need to create it based on the results of a select statement, that's when I use the create external table as select, right? So create external table to files that already exist. So maybe I have a process in Spark, or I have a process in Azure Data Factory that comes along and creates these files for me. Then I would use this. If I have to create it via some kind of transformation, then I could use this. And then once I create this file, I can come along with ADF or some other tool and move it to somewhere else, or rename it, or do whatever I want with it, right? So there's a lot of pros and cons between using a CETAS statement versus using a ADF copy activity to generate these things, which we don't have time to get into. Statistics, so it's important to do them for CSV files. Parquet will create them automatically for you, so you don't need to worry about that. We already talked about views, right? And I can do CTEs on top of my views. So this has a lot of logic going on, right? So I'm using a left outer join to join it to a table, but the query is coming in, right? So I'm joining my taxi rides T to the public holidays. So these are each different data sources. So this is coming from an external table, whereas this is coming just from a open row set statement. So it shows you how, I'm not saying you should do this, it's just you have a lot of capability to do stuff like that. You definitely, when you're running queries, only return the columns you need and perform aggregations in the query, as opposed to like returning all the rows and then doing it in an app or somewhere else. If you just need a count, do a count, right? And then you do need to kind of keep in mind like your optimal file size. So generally speaking, you want your files somewhere between 100 megs and 10 gigs. So if I'm going after a data source that's 100 gigabytes, the best way to partition it would be into 10 equal files of 10 gigabytes. Whereas if I have a data set that's 1 gig, I might just dump it out as a 1 gig file, then I lose some of that parallelism, or I might split it out into 4 256 meg files and do some testing to see if that's faster. So it just kind of depends on the use case. So there's a little bit of overhead for using that distributed query processing. So some cases you're going to find it's going to process it much faster if you just have it in one big file up to a certain limit, which I would say is 10 gig is where you'd really want to kind of limit it to. But if your data set is much larger, like if you have a 100 gig data set, obviously you're not going to create, a bunch of 10 gig files, right? So you might create bigger chunks there. So you've got to scale that guidance out to the size of the total data set size. So you don't want to have too many files because that can bog you down. So what is too many? 8 is probably a good range, depending on how much data you have to process through. If you start getting, more than like thousands, you're going to have a lot of overhead, right? So, 20s to hundreds is probably reasonable depending on how big your data set is. So this is just showing different ways to kind of, use CSV to query data and keeping data sets small. And then we kind of already talked about some security. So I think we're kind of at time. I'm going to kind of end it there and open it up to some questions, I guess, if there's any.
And reminder, you may be on mute, so you might have to unmute.
Now you tell me.
Oh, I tried to keep you muted, but it didn't work.
No,
Yeah.
you just kicked him off.
Right.
So I'm curious, people that are kind of working in Azure, is this something that you guys might think about doing some processing in there, or what are your guys' thoughts? I mean, you maybe don't see the value in it, or?
I will say that I think it's a really neat tool.
Yeah, I would agree. So Ginger, last time you presented, you had mentioned some of this, right? Basically that logical data warehouse, right? And a lot of companies have data, but it's not big data, right? It's not huge data. And I think, what you had mentioned, Jason, what Ginger had mentioned last time is, I think it's a fantastic use case for, not having to build out the ETL layer, not having to do a lot of additional overhead to transform that data into a physical data warehouse, right? You still have to write the queries and do some of that, but just getting away from the whole ETL with ADF, it's a little bit better, right? But still, removing that layer, I think, is fantastic. So I think there's a lot of use cases here.
Yeah, I mean, in full disclosure, like Ginger and I are on a project right now where we're kind of using it, and it's not the long-term end solution, but it's the intermediate one, and I feel like it really enabled us to get to a data model really quickly without doing a lot of ETL, like you said, just writing queries. Then you start dealing with, I don't want to call them performance challenges, but they kind of are, right? Like if you're trying to create external tables and they take 30 minutes, stuff starts timing out and stuff like that. So you just have to really kind of put some thought into how you create this and breaking it up. So and like
it doesn't
you said,
perform as well as a database. It's just not going to.
Yeah, exactly. I mean, I think it'll get better over time, right? And as far as features, you definitely have a lot of like windowing functions and all the stuff that you'd have in T-SQL, so that's beneficial. Even though Spark is kind of catching up with some of those things, right? So like now Databricks Spark has a merge statement, right, and all that kind of stuff. So I mean, it's kind of interesting, but there's still a few functions that don't work, right? And so if you're kind of trying to choose between am I using Databricks or am I using this, so Databricks announced the on-demand clusters recently as well, so now it kind of muddies the water even further, right, in terms of how you want to pay for this. So I'd say if you're already an existing Databricks cluster, maybe the Databricks on demand makes more sense. There's no reason that you can't use both. If you're not using Databricks, I think setting up Synapse is much easier to kind of get going and get started with without having to understand all the nuances of Databricks. And then you can grow into using Spark pools or dedicated pools if your data starts growing that big, right? But I think a lot of people will just use serverless, like you said, Mark, to replace that kind of relational layer. And then especially if they're having tabular models on top of it, right? Mark's on mute.
You muted me. Yeah, no. Yeah, sounds good. Any other questions?
Jason, it's Carl.
Yep.
I just was wondering if you tried looking at Azure Log Analytics or the storage account logs. I wonder if you could correlate to see what files were getting touched.
Yeah, that's a really good idea, Carl, because I was kind of thinking about that, right? And so it's certainly, by timestamps and stuff, you could probably pull that information back. It's actually a pretty interesting idea. I'm curious how well that would work, but yeah, certainly you could probably
especially
pull
if you're
that.
the only one, you'd have to be like the only one in there, right? But
yeah, exactly, because you need some way to tag that read log entry back to the process, right? So yeah, it's an interesting idea for sure, and it would help. The other thing too is if you get in a scenario where I'm trying to run like 5 or 6 queries concurrently that are writing massive amounts of data out, or even reading massive amounts of data, you can run into storage throttling, right? Where the storage, so the Azure Storage it's kind of a unique animal in that it can scale to meet your throughput needs, but it also will prevent you from like monopolizing everything, right? So if you're writing out 10 gigs versus 100 gigs, your performance will be linear, right? You won't write 10 gigs faster than you'll write 100 gigs. So it'll kind of throttle for you and give you the amount of bandwidth that you need, which is kind of cool, right? So
you could reference multiple storage accounts too. Yeah.
Absolutely, yeah. If you needed more performance, there's some things you could do with having multiple storage accounts, or even using like premium tier storage. That's something to look at, right? That's a little bit more expensive. That's something I want to do some testing around, because I want to see if that actually gives you better performance, right? And do some testing around it. It should, right? But how much, right? And when you start thinking about the cost involved, right? Is it worth it or not? So yeah, that's a really good idea though, Carl. All right, well, that's all I got.
Sounds good. You want to show your contact info?
Yeah, let me give you guys a link to my OnlyFans.
Or you're not showing your Instagram?
You still have it? You didn't get shut down?
Not yet. They tried.
Okay. All
It was
right.
Ashley Madison you got turned off on, right?
Oh, ouch. Wow. Shots fired. Yeah. So, and like I said, if you guys have any questions about this, especially like I didn't have time to go into some security scenarios. Ginger, I think, ran into this a couple months ago where like it works from the studio, but you can't get it to work from the management studio. And it all depends on the user context of how you're coming in. And so there can be some trickiness to get that going. So I was hoping to put together a slide on it, but I haven't had time. But basically, you just need to make sure that you know how you're authenticating and that account has the right rights to the underlying data source.
Yeah, that can get tricky.
Yeah. So yeah, so feel free to email me, connect to me on LinkedIn, follow me on Instagram, subscribe to my YouTube channel. When I get to 100 subscribers, I'm going to actually start producing content. So there's your nudge to subscribe to me, even though there's nothing out there. But there will be someday, I promise, eventually.
Well, cool. Hey, Jason,
All
I
right.
appreciate it. Tons of great information and always entertaining.
Yeah, thanks, Mark.
Appreciate it.
That's going to be tough to follow. Hey, Mark.